Okay, meanwhile, yeah, hello, Anvesh, hello. Yeah, Anvesh actually our winner from last competition and from the first marathon, data science marathon that we made a couple of weeks ago. Nice to see you here. Hello, Jacqueline. So I just like to repeat that today in the final part of our webinar, of our workshop, we will do the giveaway of books, from our sponsor Pact, and actually free amazing 20 books you can get if you will be lucky. 10 lucky people will get these prizes from us today. And of course, a part of this, you will get a lot of practical knowledge and tips about MLOps strategy. And of course, a part of this, as usual, we are going to make a practical session. So please, if you don't have the registration in our Newton platform, free test drive version, so please take your time to register and to enter. In the second part of our workshop, we will do a practical live demo with you. Okay, so let me see if we have some answers from our pool. Okay. Let's wait 1 minute more and we will start. Okay. So let's see. So we have junior data scientist here, welcome, and data analyst and analytic managers. So someone heard about MLOps, but not everybody. And yeah, wow, it's different opinions. So you found the most challenging scaling your model deployments, poor visibility, code is in different environments, IT gaps. So wow, a lot of topics that we need to cover today. And so let's start. Okay, I would like to give the word to Andrew first. So Andrew and Harpreet, please, let's start.
Awesome. Yeah, thank you, Yulia, for the great introduction. My name is Andrew Glutt. I'm the partnership director here at Newton AI. We're super stoked to have all of you joining us today from all around the globe. Today, we're going to be talking about MLOps, and we're going to definitely address some of the different challenges that you're seeing within your environment. And today we have Harpreet from Comet, who's going to be sharing his experience with MLOps from a strategy perspective. Yeah, I'd just like to quickly thank Yulia for organizing this, all of our participants, and then Harpreet, thank you as well for joining. Before you get started, Harpreet, it would be great just to get a little bit of an introduction to you, a little bit about your background, maybe some milestones in your career that everyone could hear about. We just love a brief introduction before you get started.
Yeah, for sure, Matt. What's going on, everyone? Happy to be here. Happy birthday, Andrew. Yulia, thanks for having me here, and all of you guys, thanks for joining, Matt. We're gonna have a good next half an hour or so. I'm excited to present. So yeah, my name is Harpreet Sahota. I'm a data scientist at Comet. We're essentially a experiment management platform because managing machine learning experiments is hard. It's multivariate, and we make it easy for you. So Comet is definitely a big player in that space. In terms of me personally, prior to working at Comet, I was a lead data scientist, starting a data science team from scratch. Like I've done that twice. Before that, I was a biostatistician. Then I was an actuary, studied math, stats, and all that stuff in grad and undergrad levels. Couple of milestones. I mean, I feel like every year something new happening, right? This field is so cutting edge and so exciting, so new. Personally, milestones for me is now launched a podcast just recently, about a year and a bit ago. That's seen some good traction. So definitely check that out if you guys are interested, called the Artists of Data Science. Get an opportunity to speak to a lot of really cool people. And I mean, that's the only milestone. I had a baby 18 months ago. I guess that's first child. I guess that's a pretty huge milestone. I don't know if that's a milestone you guys cared about, but yeah.
Yeah, appreciate that. Thank you so much for the introduction. We're super stoked to have you today.
Yeah, here, happy to be here.
Cool. Feel free to kick it off when you're ready.
All right, hey, let's get down and dirty, guys. Let's do it. So I'm gonna pull up my screen. It's gonna be on presenter mode, so I'm not gonna be able to see your questions or your comments. But if you do have questions or comments, you guys can leave them in the chat. I'll try my best to give you a decent answer to those when I can. So let's go ahead and get started, my friends. So again, my name is Harpreet Sahota. I'm a data scientist at Comet. I'm excited to be here with all of you today. Huge shout out to Newton for the opportunity, and also for all of you for joining me today. I've got an exciting agenda for today's talk. Specifically, we are going to walk through 3 lessons from the field in building an MLOps strategy for your organization. Let's go ahead and talk a little bit about that. Just a quick overview of what we're going to cover today. So we're going to start off by discussing what MLOps is and dig into why it's being discussed so much in our field and why it seems like every ML organization worth its salt is talking about and beginning to invest in MLOps. Then we're going to dive right into lessons learned from the field and how you can think strategically about implementing MLOps in your organization. And we're going to do that by first talking about when. When do I start investing in MLOps? You're probably wondering at what point it makes sense to start thinking about an MLOps strategy. What are some of these signals coming from your model development process that MLOps should be considered? Don't worry, we're going to cover that in this lesson. In the next topic we're going to cover is how to start intelligently investing in MLOps. You've probably had some success with your early machine learning initiatives, but eventually you're going to reach a point where it makes sense to adopt an MLOps strategy. And when that time comes, how should you think about team structure and collaboration between ML teams and the other business units? There's a wide selection of MLOps platforms ranging from scrappy in-house solutions to managed vendor products. Which one's going to be the best for you? Which one's going to make the most sense for you and your organization? And then finally, we're going to talk about how to measure the success of your MLOps strategy. MLOps is a developing discipline, and it's critical to understand how to measure the success of your MLOps strategy. How are you supposed to justify to your various stakeholders that this investment is worth your team's time and effort? My goal with these lessons is to help you avoid making mistakes and set you up for successful implementation of MLOps at your organization. That way, you can maximize the likelihood that the work your data scientists and ML engineers do actually drive value for your business. So if you're in the ML space and you haven't been hiding under a rock, then you for sure notice that MLOps is starting to pop up everywhere. The most prestigious publishers in our field are writing tutorials. Pioneering and innovating companies are writing engineering blogs filled with overviews of how they're approaching MLOps. And we're starting to see MLOps specific job postings pop up on job boards. For many, however, MLOps is a relatively new set of ideas. So at a high level, MLOps is a set of practices and tools designed for teams to reliably and efficiently train, optimize, evaluate, package, deploy, and monitor their machine learning models in production. Developing and deploying machine learning models is complex. And without good tooling and processes and practices in place to deal with it efficiently, your team will struggle under the weight of laborious manual and ad hoc engineering tasks. So we have to deal with a lack of lineage and explainability across workflows, models that underperform, models that decay, and data lakes filled with orphaned model binaries. We've all been in those scenarios where we put in hours of work, but our model never makes it out of the lab or promoted to production. These are just some of the challenges that we face. And this is where an MLOps system can address many of these pain points. So when you're building out your MLOps strategy, you want to be equally an architect and a mason. That means you want to approach it from both a technical and a strategic perspective. While there's a ton of information available that details how to build an MLOps platform from a technical perspective, there's much less information available on how to think about MLOps strategically. And we have to wear a couple of different hats, right? So as practitioners in the field, we understand and appreciate that machine learning is incredibly hard and multivariate. From the problems being solved, the modeling strategies being applied, right down to the size and maturity of machine learning teams. But then as leaders, we're faced with a unique challenge, and it's a difficult challenge. And it's one that is centered around developing a plan of action, and that is strategy. In particular, we need to know when to start building our MLOps strategy, how to start building our MLOps strategy, and how to measure its value once implemented. So let's jump right in and talk about when. When do we start implementing an MLOps strategy? To start, let's consider this quote from Chris Brossman, who is the director of data engineering at The Real Real, an e-commerce company selling clothing and accessories that went public 2 years ago. And Chris says that MLOps is needed now more than ever as companies transition from using machine learning in an exploratory way to using it as a core operational software component to deliver value. And implicit in this quote is an extremely important point, one that's been widely written about and one that I'll repeat here. It's a pervasive issue in our field. Many modeling projects fail to reach production in machine learning teams. This probably has to do with general machine learning maturity and organizations having trouble articulating where and how to apply machine learning to drive real business value. It also speaks to an important trend that's happening as teams evolve and become more mature. Not only will your models become essential pillars of value generation for your business, but the pain and frustration your teams experience will grow as your team starts to deploy models into production. All that, however, can be solved if you have an MLOps strategy. But it's not always crystal clear that something in your process is broken. So what are these pain points and how do you know if your team is experiencing these problems? Chris Brossman, who we're already familiar with over at The Real Real, heads up a team that's seen significant growth over the last few years. He's got 25 people on his team at The Real Real working on building and deploying machine learning models. He recently shared a few early warning signs with us that could be useful indicators that our teams are ready to start thinking about MLOps. Let's run through a few of them. So if your team suffers from inefficient workflows and manual processes where every step from data extraction to cleaning to modeling to deployment is manual or done with custom-made lines of code, then your team may be ready for an MLOps strategy. If your team is still copying code between projects, doesn't have a repo of useful code snippets, and is having to reinvent the wheel for every project, then your team may be ready for an MLOps strategy. If your team is always slow to start because of long ramp-up times with tooling, and you've got machine learning engineers having to constantly context switch between projects, then your team may be ready for an MLOps strategy. If your team feels like the projects are always lagging when deployment time comes because it seems like supporting teams are always busy, stay with me, everybody, stay with me, then your team may be ready for an MLOps strategy. And that's not to mention many of the other symptoms, from it taking days or even weeks to retrain a model, scaling issues where training is blocked by time-consuming data transformations, to the cost of carrying crushingly high interest rate technical debt, like being locked into a simple model type due to your deployment pipeline, right down to concerns regarding lineage and traceability. For example, when a deployment breaks, how easily is your team able to tell where the failure has occurred? Look, I know that many of us don't work on super large teams of data scientists. Many of us are much smaller teams. Some of us might be on teams of 5, maybe even teams of 3, or even the only lonely one hero data scientist. But teams of all sizes will eventually feel at least one of the pain points at some point in their evolution. By the way, to the heroes out there, I feel you. Cheers. I've been the only data scientist in an organization a couple of times. Let me tell you, even as a team of 1, I wish I understood the value of dedicating time and resources to at least learn about various MLOps strategies and tools so that I could alleviate the pain I was having. All right, so let's just summarize the win very quickly. So you should start implementing an MLOps strategy when your team size starts approaching 10 or more people. And if you're already past that threshold and have a team that's larger than that, don't despair. It is never too late, almost never. Next, you want to keep an eye out for the numerous warning signs that we just walked through. And finally, even if you're a small team new to the field or you're not already aware of the importance of MLOps, start educating yourself before it is too late. Now that we know what signs to look out for and have an idea of when the timing is right, many questions still remain, particularly the how. How do we start implementing an MLOps strategy? So we know that machine learning teams come in all shapes and sizes, both in terms of their composition and their procedures and their processes. Each team will handle data sources, modeling strategies, and taking models into production in their own way. Some teams deliver mission-critical models serving real-time predictions to customers. Others might plow through offline batch jobs that generate predictions that inform internal business decisions. Whatever your team looks like, I can guarantee you that it's in your best interest to consider some general principles for how to start implementing an MLOps strategy. Our friends at The Real Real and Ancestry.com have got us covered. They've shared some awesome lessons with our team at Comet, and I'm happy to pass them along to you all. The first lesson pertains to team size and structure. What's the critical mass in terms of team size, where it becomes in your best interest to invest in someone to manage your MLOps strategy full time? And once you've hit that critical mass, what's the structure going to look like? Who is this person that's going to be responsible for implementing MLOps on your team? What qualities do they possess? This person, who we can call an MLOps architect, is likely going to be someone with some DevOps background, maybe who's had some prior exposure to machine learning workflows. Although it's recommended, this exposure to machine learning is not like a hard and fast requirement, because you can always bring smart, intelligent, hardworking people up to speed through robust training programs as part of their onboarding process. Your platform is going to become complex and an important product in and of itself, with a lot of different talent plugged into it. So it's worth having someone entirely dedicated to building and optimizing it. Chris at The Real Real suggests starting to think about hiring a full-time MLOps architect once the number of people building models on your team reaches 10 or more. The second lesson has to do with creating value for your business using machine learning. This has so much to do with the internal structure, communication, and collaboration between your machine learning team and your business stakeholders. It is a crucial component to get right. So if you're developing a machine learning organization, you're probably thinking, how can I create value out of machine learning for my business? And the key to successfully delivering value to your business using machine learning is to bring data scientists on as strategic partners. So data scientists and business experts each have a piece of the puzzle. Data scientists know which problems are feasible to approach with machine learning. They know the abilities and limitations of machine learning, but might not deeply know your business or industry. The business folks have a deep domain expertise. They understand the organization. They understand the industry. They've got the savvy. They've got the acumen. They know how to find business value, but maybe they don't it's likely they don't understand the limitations of machine learning. Key is to bring these two personas into the same room to connect the pieces of the puzzle and identify which problems are both feasible from a machine learning perspective and what creates massive ROI for the business. And this ties to another important lesson for implementing an MLOps strategy, which is communication and reporting. of machine learning team initiatives outside the core machine learning team. A common pain point we see in teams is data scientists working in silos. And when this happens, they're missing out on indispensable collaboration with business stakeholders and domain experts who possess valuable insight into how these models are going to drive business value. When crafting your MLOps strategy, it's imperative that you build into the strategy a consistent and transparent reporting structure so that the stakeholders that are outside the machine learning organization can track modeling progress and the subsequent impact on the key outcomes that you guys are targeting. So the team at Ancestry.com are building models that scan billions of documents, identifying new information sources to add to the lineage records for individuals using their products. Their NLP team lead, 𝘛𝘩𝘦 has shared a bit about how they're solving this problem of reporting and communication. The team at Ancestry tracks their model development process live and transmits those live model development updates to live reports that are shareable and accessible by anyone who wants to access them across the company. They're not limited just to the data science team. On top of that, they have regular monthly meetings with where the machine learning teams present their research progress to the business stakeholders, and they realign for the next research and development push. The takeaway that 𝘛𝘩𝘦 leaves us with is that we should design a reporting structure so stakeholders outside the machine learning organization can track modeling progress and impact on key outcomes. We talked about team structure and reporting, but what about tooling? So when it comes to internal tooling and processes that support their machine learning workflows, most teams we've spoken with mention two values that rise above the rest: modularity and reusability. Like, I know we all love a little adventure, but one place I wouldn't want to explore is the pipeline jungle. You might have heard of this place: pipelines all over the place, ETL pipelines, training pipelines, evaluation, deployment pipelines. If this is your current situation, I want you to know that it is possible and highly recommended to build reusable modular components that standardize the way these projects are run. So some areas where Chris Brossman recommends considering building these reusable components are data generation, data transformation, data exploration, experiment tracking, model evaluation, and deployment. Each of these steps is organized into modular reusable components, which forms the foundation of the machine learning process at the real. When executed well, this enables continuous training practices that will lead to much faster research and development and durability and flexibility of your platform. All right, so even if you've built out a machine learning platform that's robust, reliable, and remarkable, as your team matures, your MLOps architect is still going to feel the growing pains. And sometimes these growing pains come with expensive remedies, with vendors writing up prescriptions to help alleviate your pain. And there seems to be an infinite number of tools on the market today, ranging from massive end-to-end platforms to highly specific open source modular tools. It can be incredibly noisy and challenging to parse all of the options and identify the right choice for your team. Despite all of the noise in the space for machine learning tooling, there are still some rules and heuristics that will help you approach the selection process with confidence that you will make the right decision for your team. Here's at the Real has a useful framework for thinking about vendor purchases, which we are sharing here with you. And the first point is to look for tools that solve specific problems that your team is experiencing. So how do you do this? Well, first you need to make sure that you're gathering information from your team about what their pain points truly are. You've got to figure out and ask them, what are the manual tasks that they have to perform? You got to figure out where cycles are taking longer than they should. And then you got to find out where the largest opportunity for improvement is. This is going to help you dramatically narrow your focus, right? And your tool search. Because the last thing you want to do is purchase a tool that tries to solve all the problems. because those type of solutions are expensive and they rarely correlate to your team's specific needs. The second point is to develop data-driven evaluation and selection processes before engaging with vendors. So it's hard to quantify, communicate, and convince stakeholders of the value proposition for improving a workflow. The best approach here is to create a data-driven framework, and you do that by first clearly specifying the features you need to have. Then you identify specific workflows that you want to see addressed. Then you have your team test and verify with a pilot. This is going to help provide clarity when it comes time to make a purchase decision. Finally, you want to structure your proof of concepts to be as organized, thorough, and fast as possible. Life is short, my friends, life is short, and the craft is long. So it's in your interest to run the swiftest POC you possibly can. So don't let this process become drawn out, laborious, or have internal priorities. Just keep pushing it down the to-do list. Otherwise, nothing's going to get done. You're not going to have anything to test. So you need to avoid spending time like half evaluating a tool, because at the end of the pilot, you're not going to have the robust data that you need to make a good decision on whether you should buy or not. So try your hardest to condense this evaluation into 1 or 2 sprints. When it comes to platform building and vendor selection, it's a good idea to value flexibility in the tooling. So technology is evolving rapidly. Best practices are still forming, and your team is evolving and changing rapidly as well. So you want to avoid vendor lockup. And the way you do that is by using modular tools or tools that come with built-in mechanisms for easy data transfer. That way you don't get stuck again in 18 months when your team's needs and priorities have become more sophisticated. So get in the habit of keeping your code, pipelines, and processes modular and reusable. Hire an MLOps architect once there are more than 10 people building models on your team. You want to bring a data scientist and business stakeholders to connect their respective pieces of the puzzle and keep communication transparent between machine learning teams and your business stakeholders. And you want to look for tools that solve specific problems and value flexibility above all. All right, so that's enough of the how, right? So we've talked about when and we've talked about how. Let's talk about measuring the value now. We need to talk about measuring the value of your MLOps strategy once it has been implemented. Measuring value is going to take different forms at different stages of the model lifecycle. And that's because machine learning operations, MLOps platforms, need to support both experimental and automated workflows. So let's get into this a little bit here. At a high level, an experimental process for building a machine learning system involves pipelines with various components, everything from problem identification to data collection to data cleaning, all the way to feature engineering and model training. This is an iterative process. We can spend weeks or months in the process of improving model performance. And as these arrows here indicate, this is an iterative and experimental process. So expect to experiment. You might completely revisit model requirements. You might need to collect more data, and you might need to label data. Because of these feedback loops, and experimentation is necessary because of this. So a lot of machine learning work is non-deterministic and highly experimental. How are you supposed to measure the value of a platform that's built to support something that's a moving target? Are you supposed to measure the value of a platform solely based on its ability to get you to a desired evaluation metric? Maybe a better way to think about measuring the value of your strategy is its ability to unlock faster speed and greater scale of experimentation. So at Uber, which is home of one of the most well-known machine learning platforms in the world, they have their platform called MLOps, and they've got some useful metrics to track efficacy of these experimental workflows. So what you want to do is start making a comparison with so basically compared to not using the platform that you've built, you want to assess the marginal impact on time to model ready data set, That's everything from collection, cleaning, labeling, feature engineering, transforming. You want to assess the marginal impact on time to production ready models. That's everything from research and development to experimentation to optimization to testing. And you also want to assess the marginal impact of your platform on volume of experiments over a fixed period of time. Essentially, how many hypotheses has my team been able to test? What does that, how does that compare when I have a platform, an MLOps platform, versus when I didn't have one, right? So when you're at the development stage, these indicators will give you a good idea whether your MLOps strategy is making the impact on your team that you want it to. However, things start to change once you get ready to go to production. And this is because once you have a production ready model, the steps between finalizing that model and getting that model into production should be as automated as possible. In most cases, this deployment process will consist of something along the lines of testing, packaging, model deployment, monitoring, alerting, retraining. This all should be an automated process. And the one area of the deployment pipeline that will be hard to automate will be production monitoring, where data scientists may need to dig into data drift and other production issues to diagnose whether what's happening in production warrants a retraining or not. So how are you supposed to think about measuring value here, man? Like this is all hard, multivariate, moving targets. How are you supposed to measure value? So the Michelangelo team at Uber has a CI/CD, that's continuous integration, continuous deployment system built for continuous model serving and monitoring. And they've adopted a conventional measure of DevOps success, and that is engineering hours saved on manual tasks, right? So comparing where engineers are spending cycles before and after implementation of your MLOps strategy, this is going to give you a good sense of the utility and value it's providing your team. So let's go ahead and wrap up here with a recap of what we covered so far in this presentation. So adopting an MLOps strategy is a crucial and challenging set of decisions for any organization. But my hope is that we can take away the key lessons and insights that some of the best machine learning teams in the world have shared with us, so that we're well prepared to tackle this for our teams. So the first lesson was that there are clear warning signs and pain points that will emerge to indicate that it's time to start investing in MLOps. We've touched on a number of them during this session. Ignore them at your own peril. Secondly, building clear lines of communication to business units will set your team up for long-term success, ideally with a dedicated MLOps architect leading the way. Third, you want to build reusable platform elements to standardize workflows and be data-driven and efficient with your vendor selections. And finally, when measuring the value of your platform, optimize for speed and scale of experimentation around model development and time savings and automation around model deployment. All of these lessons will set you on the path to success. And it's an important path to start walking. As a final note, I want to offer a couple of thoughts about where this field is headed in the near future. In the near future, a lot of these tools, processes, and best practices will become standardized, and the organizations who adopt them will benefit from outsized returns with their machine learning initiatives. Your adoption will impact your team's success and your success in attracting top talent and your success of your organization for years to come. My friend, it's been a pleasure to be with you all today. Once again, we're Comet. We help data scientists and machine learning practitioners at some of the world's best machine learning teams build better models faster by providing a suite of MLOps solutions. We're committed to enabling data science teams and helping them track, compare, and explain and optimize their experiments and models across the entire model lifecycle. And you can catch a glimpse of just how we do that by giving us a try. So go ahead, pull out your phone, take a picture of this QR code, have this open on a tab so that you can remind yourself to go and try comment. If QR codes are not your thing, it's all good. Go to the URL right there, tinyurl.com/try comment. With just a quick pip install and a few lines of code, you'll be well on your way to managing experiments like the best of them. And if you like, I'll be happy to leave a link in the chat here to a series of blog posts and notebooks that kind of walk you through the process of how to manage your experiments with comment. I'll be sure to leave a link right here in the chat for you guys. Thank you guys so much for your time. It was a pleasure to be here with you today and to share the wisdom we've learned from some of the best machine learning teams in the world. Shout out to Newton for making this an awesome event. Let me know if you guys have any questions. Thank you again. My name is 𝙒𝙧𝙧𝙦𝙦. I'm a data scientist at Comet, so feel free to connect with me on LinkedIn. Go ahead, you can scan that QR code. It should open up the LinkedIn app on your phone, and you can connect with me. Be happy to connect with all you guys. Just add a note that you joined in on the presentation. That is it for my presentation, friends. Remember, you've got one life on this planet. Why not try to do some big? Cheers. And I guess now would be a good time to take on some questions.
Harpreet, awesome. Thank you so much for that. While we wait for some of the questions to come in through chat, feel free, everyone, to just go ahead and put your questions in, and we'll get Harpreet to go ahead and address those. Just wanted to kind of highlight a couple of key takeaways for myself that I really appreciated. One was communication between, data science or data analyst teams and business. That's definitely a huge challenge, and I really appreciate you highlighting that as well. And then another one that I thought was very interesting were those warning signs that you had showcased. Companies are across the board on their AI maturity, right? They could be either just starting and experimenting, or they could have hundreds of data scientists. So just constantly reminding ourselves to, keep reskilling, keep understanding, what are the different tools on the market that we can leverage to help ourselves along that journey is definitely useful. So I really appreciate, all of the insights that you gave us today. Very interesting, going from, the very beginning, from, just data gathering the data, preparing it, bringing it into the pipeline, bringing it into production, as well as measuring the value. I think all of those things are huge pain points that we're seeing as well. So I really appreciate you highlighting all of that.
Yeah, absolutely, man. Yeah, it's definitely been struggles that I've gone through in other companies. So it's awesome to be able to chat about it and share that experience. I think, but for many aspiring data scientists out there, they think that every company is like mature and ready for data science because you just hear about it. So I guess there's a bit of that selection bias, the survivor bias. We only hear about the cutting edge stuff that other companies are doing, and we just assume every company is like that. But that's actually not the case, right? A lot of companies are very I don't want to say immature, it's not the right word, but they're just starting out with data science. And they might not even have data management or data governance or all that upstream stuff in place, because as data scientists, we're end users of data at the end of the day. As data scientists and machine learning practitioners, like at the end of the day, we use data. So we depend on having good data management, good data governance, good data architecture and data engineering in place to facilitate the work that we do. Yeah, I think I got off topic there for a second.
Yeah, we don't have too many questions. It looks like your QR code was successful. We got a lot of good feedback as well. So yeah, we'll just wait another minute here for questions, and then we'll talk a little bit about kind of what we're doing here at Newton. And how we're addressing some of the problems like you had mentioned, but not all of the problems, right? So
yeah,
it's definitely a very interesting topic. MLOps, like you had mentioned, is becoming more and more public and publicized and things like that. So I thought the quotes that you provided were also really awesome too. So appreciate that.
While we wait for questions to come in, I just want to take a second here just to showcase that I'm really proud of these articles that I've written here. So I've got a couple of really helpful tutorials. One is specifically dealing with fraud detection and imbalance classification. kind of giving you an overview of how to think about the different metrics, how to think about recall precision, true positives, false positives, true negatives, false negatives, things like that. But then also it's a real cool series of notebooks that are meant for you guys to play with. So if you click through each one of these notebooks, they're set up in such a way that you just copy it into your own drive, right? They're Collab Notebooks, code fully fleshed out that'll help you learn not only how to use Comet, but learn about what metrics to examine and how to balance data. And then I've got imbalanced classification demystified, which is another cool tutorial. So definitely check that out. So yeah, any questions starting to come in there?
Yeah, we did get one. Regarding the company size, 10 employees, a proxy for company size or data maturity. So I'm not sure if that was less than or greater than there. Yeah.
I don't know, man. I've met a lot of really tall toddlers in life. Like I've seen some large children. So I don't know if size necessarily implies maturity, and I think that that's true for size of a company as well. I think the size of a company should not be conflated with their level of maturity. I think maturity has to do with practices and processes that are in place. So can a smaller team be further along the data maturity? I think definitely, especially if there's good processes upstream.
And then the next one was, how would you advise a young MLOps team to build their skills? Other than joining our master classes, of course.
I mean, MLOps is like kind of, it's developing, it's a developing field. So the best way I think to learn is being involved in communities and following a lot of thought leaders in MLOps. So in particular, there's the MLOps community. I think it's just mlops.community. Really active, super active Slack channel with a lot of, I think like 6,000 to 7,000 people in that Slack channel, just sharing knowledge. If you got questions, go on there, ask questions. Headed by Dmitros Brinkman. He's amazing. He shares a lot of great knowledge, and then that community is super active. You can follow my friend Mark Freeman, who's also a thought leader in the MLOps space. So definitely follow Mark on LinkedIn. He'll be able to share some. I mean, he's got a bunch of blog posts that are being published soon, I believe. He posts a lot about it on LinkedIn as well. So that's where I would start, right? If you're a young MLOps team and you need to build your skills, start by joining communities, because I don't think there's a lot of information out there. Like there's a few books here and there, but we're kind of building the airplane while it's flying right now.
Awesome. Thank you so much. All right. Well, appreciate that. Thank you everyone for all of your great questions. Now we're going to take a look at what we're doing here over at Newton. So yeah, a lot of what you had mentioned, Harpreet, was, okay, we're doing a lot of this manual effort across all of the life cycle, from data preparation to deployment. And part of what we've understood is that these are problems that we're seeing, with our customers and the community. And so we've developed the Newton AutoML solution. It doesn't require any type of coding. It allows you to have full automation from not data preparation, but data pre-processing to deployment, as well as some model lifecycle control tools in there as well. And we also help with bringing models to production quickly. You had talked a little bit about creating a pilot quickly. That's something that we've seen as well, is that you can come up with an idea, you can begin to do the pilot, but then it kind of falls off over some time. So part of what we're doing here at Newton is helping be able to create those models automatically and quickly. And when you're also talking about deployment of ML models, we've seen 90% of all machine learning models never actually make it into production. So 1 out of the 10 data scientists' workdays actually ends up producing something useful for the company. And some of the problems that you were addressing and talking about was, one, leadership support. So data scientists and data analyst teams need support from the upper management. And that effective communication that you highlighted so well between the data scientists, engineers, the business teams, the DevOps teams, all of those things need to come together in order to create a successful ML model or MLOps strategy. And then the accessibility of data is another area that we've seen. And I think you highlighted that well, looking at all the, disparate data sources and how can we bring those together? How can we integrate what we're doing from a tools perspective in order to bring something into production quickly? And even if you look at Netflix, they were awarded $1 million prize for creating an algorithm that they never even brought into production. So it's not just the small companies, or not small, but the companies that are starting out that are having issues. It's even the companies who have some of the best recommendation engines in the world. And when we look at how MLOps seeks to improve automation, so reducing that mundane and manual tasks and improving the quality of production models while focusing on the big business and regulatory requirements. So when we look at all of the compliance issues, we want to have explainability in the entire process that we're having. So I think when you were talking about transparency and reporting, it is extremely important. And one of the big problems that we see is the automation of the process. And when you were kind of sharing with us the entire MLOps overview, starting from the project idea, finding the data scientists, retaining those data scientists is extremely expensive and can take a lot of time, setting up the infrastructure for your machine learning efforts, analyzing the data, processing, cleaning, and collecting it. On one of our last master classes, we had Fabio from Microsoft, one of the directors of data and analytics, and he's mentioned that he spent 3 years going around Microsoft collecting data just so that he could start his experiments on creating customer experience. And so that's, not something that, is a one-off. That's what a lot of people are experiencing. As well as you talked a little bit about feature engineering and modeling. These can take up a lot of time and effort. And like you had mentioned, a very iterative process. And then you have to find people who can actually bring the models into production, right? Because we can build the models and, experiment, but if we're not actually deploying them, then what's the point, right? We're just spending resources on a buzzword. And of course, if you get bad results, then you have to start all over again. If you are successful, then you can start making predictions and driving business value. And we've tried to simplify this process by creating something where you can, make a machine learning model just with a few clicks. So all you need to do is upload your data, train your model, and then you can begin making predictions, whether it be on the web via REST API, or even download the model and deploy it. And this helps us bring models to production quicker, reduce the cost of implementation, as well as the cost of support. So what's the next big problem that we're experiencing? Quality of production models. I think Harpreet, you brought up a lot of good points about, hey, we've created models. When do we need to retrain them? What's the quality of the model? Are we bringing value back to the business? So we can ask ourselves, what does my data consist of? What are all the different types of pieces of information that we're gathering from, the enterprise, whether it be from our CRM system, whether it be our ERP system, whether it be, surveys that we've done with our customers. What are those important features that are influencing what we're trying to predict? And then we want to understand why our models are making certain predictions. That way we can bring back explainability to the business. And then when we consider when do we need to retrain the model, right? We bring models into production, we're getting value out of it, but as time changes, as behaviors of our customers change, so does the resulting model and how well it can maintain the quality. So when we look at what does my data consist of, within the platform, we've created our exploratory data analysis, which is an automated process that lets you look at different types of features within your model and how they're associated with the target variable. So we can kind of see what the overview of our data is, what are the correlations of different values, what are the different outliers, what are the different time dependencies if it's different, if it's dependent on a time series problem, for example. When we look at what are the important features, we've created a feature importance matrix that helps you understand what are the top features that are influencing your predictions. And this can help you with that data gathering part of the mix, right? So you've got lots of features that are influencing your prediction, but maybe there's features that aren't influencing your prediction. Maybe you want to remove those from your data pipeline and add new additional features that might make an influence. We kind of saw the old way. Everything kind of highlighted in pink is areas that Newton has different ways of addressing. These areas, from automatically spinning up infrastructure, doing exploratory data analysis, feature importance matrix when we're looking at how we're doing our modeling. And then the third problem is business and regulatory requirements. So we look at why the model's making certain predictions. We've baked in a model interpreter so that you can look at each individual feature and understand how that feature is influencing your predictions, as well as adjusting those particular values to see if it influences your prediction. And we'll see that in the live demo and how we can create some business insights and actions on that as well. And when should I consider retraining my model? We've created our historical model to data relevance indicator to help with that. So every time you create new predictions, you can see if your data is still relevant. And how can I validate my model on new data? So we can look at all the way from the beginning when you first create your model to when you're creating new models as well. And so we kind of have this web that shows you the quality of your model as well. And there can be, model degradation over time. And so we can help confirm the health of our models so that we don't lose out on revenue or we don't lose out on customers that may leave or churn. And that's where we've created the model interpreter to help with different types of experiments. And after we've been making predictions, that's where we've laid in the model to data relevant indicator. And from a deployment perspective, whether it's doing web predictions, which can be very helpful for like a data analyst, for example, whether we can access it via API or a downloaded model, we can provide all the necessary C code in order to deploy the model so that you don't have to spend time on coding. So overall, the different what, where, why, and when be addressed with some of the different features that we've deployed within Newton. So overall, Newton ML, AutoML will help bring in machine learning models faster, which can reduce costs. It can also be able to spin up lots of different experiments simultaneously. So one of the metrics that you had mentioned from Michelangelo was, how many experiments have we created over a fixed period of time? So we can actually create, 3 or 5 or 10 models simultaneously and kind of walk away and then come back, and then we can analyze those so we don't have to spend time with all those reiterations. And also another challenge you had mentioned was, being able to have long update times, right? And so by leveraging auto machine learning, we can decrease this time, and also integration across all the different types of tools we're using, as well as being able to control the process. So right now we're going to go into a live demo so that we can see the platform. If we'll maybe take a quick 5-minute intermission here, since we've all kind of spent a little bit of time here. So we'll sit back for about 5 minutes. If everyone could scan the QR code and go ahead and enter the free test drive, and we can walk along and actually do a machine learning experiment together as I do the demo. And Yulia, if you want to jump in here and share a little bit as well.
Yeah, thank you, Andrew. Meanwhile, we are waiting for people to join our platform in order to make a practical session right now. I'd like just to remind that after our session, we will do the giveaway of amazing books about MLOps strategy. Maybe I just would like to share with you, can you give me a, yeah, okay, the right of sharing which books we will give you to 10 lucky persons today. So one of the book is Engineering MLOps, okay? So every of this book is have a cost around 45 dollars, I'm sorry. And this is a new edition, new trendy books. And actually, I remember that Harpreet, you asked me to save one for you, so I will do this definitely. And this book will go to you directly from our sponsor pact. And also one of the 10 lucky persons will get it. The second book that we will give today is Developing Modern Database Applications with a PostgreSQL. So also very interesting, very useful for you to improve your knowledge, your skills. And the third one, so Essential by Spark, it's also new edition, new trendy book. So please get chance. If you are looking now, if you're in live now in LinkedIn, so please you still have a chance to go to Zoom. And we will do this giveaway, selecting the numbers of the registrations from Zoom. So please come, and afterwards we will announce our winners in our Slack channel. So after the presentation and after live demo, we will share with you also our Slack channel. Please welcome. It's a growing community where we will share knowledge, experience. You can ask your questions. You can find maybe employers or clients or friends. So please join us, and good luck with the book away. And now I think everybody is already on the platform, and we can go directly to a live demo and the practical session.
Awesome. Thank you so much for that, Yulia. I think there was a question about if they're able to buy the books in India as well. So maybe if you can look into that, or if you have the answer, just let me know.
Yeah, I will answer. Mm-hmm.
Oh, 1 second here. I need to re-log in. I just got logged out.
I think, yes, you can buy it in India anyway. I will check it with the pact, but even if you are in India, we can send to you ebook copies, okay? So you can enjoy also this book in electronic version.
Okay, awesome. All right, I am going to reshare my screen. All right, awesome. Thank you, everyone. So right now, we're taking a look here at the Newton AI platform. As you can see, I have quite a few solutions, and it's all tile-based, so you can track all of the different models that you're building.
And second, I think that people who just joined our platform, you will see clean screen only because you don't have your machine learning experimentals yet. But anyway, as Andrew mentioned, you can run unlimited machine learning models in our platform. And now just try to repeat the steps that Andrew will show you, and it's very easy, and we will do it together. And please ask us questions in chat if you have some questions, if you have some need some help, and we will stop and help you. Okay.
Yeah, perfect, Yulia. Appreciate that. Yeah, so you would see a blank screen here if you've just joined in. And as Yulia mentioned, you can build as many models as you want simultaneously, and it's all automated through Google Cloud. So if you can all join me, on the top right side, we have Add New Solution. So just go ahead and click that, and we can name it Cross-Sell. And we'll just say MLOps as we are having this session. Just click Next. As you can see, there's three main steps that you can take. You have your dataset tab, you have your training tab, and then your prediction tab. We have an option to upload our own dataset. We can also select it from our own dataset from storage, but today we're going to be using the preloaded dataset. So just click on the preloaded datasets. Here we've got a number of different options. So let's look at a finance use case. And we're going to be clicking on the cross-sell preferences binary classification problem. So go ahead and click that. Once you've selected it, you'll be able to take a look at the data set. So here, what we're trying to do is predict whether somebody will subscribe to a bank service or not. So we've got different job types. This could be categorical data. We've got when we've last contacted them, days from the last contact, and even some macroeconomic information about the consumer price index or the European bond number. And then finally, the target variable, which would be subscribed or not. So in this case, 0 means they did not subscribe, and 1 means that they did subscribe. So all of this information comes from our CRM data or macroeconomic information that we pull from the market. So once you've selected that, just click OK. And then the last step we need to do in the dataset tab is select the target variable. And with the preloaded data sets, it is already pre-configured to subscribe. So now you just click Next. Once you've selected your target variable, you're now into the training tab. And here it has automatically understood it's a binary classification. So whether they subscribed or not subscribed, the metric is accuracy. And all of this is set kind of on the automated perspective. If it's not the test drive or preloaded data set, then you can make some of those selections, and then you just click Start Training. So at this point, what we're doing is automatically setting up a virtual machine to train your AI model. You can also set up text notifications so that when the training is complete, it will text you saying, hey, your model's complete, now you can start doing predictions. In this case, this particular problem takes a little over an hour to train. So I'm going to go ahead and go back to a pre-trained model. So I'm just going to click Solution Details. So at this point, everyone who's gone through this process with me step by step, once your training is complete, then you can take these following steps that I'm going to show you here. So as you can see, it took just a little over an hour to train the model. And right now we have the model is 100% trained. If we scroll down, we can see the model quality index as we saw in the presentation earlier. And accuracy was the target metric, and we were able to get a 91% accuracy. Now, this is kind of the fun part, is making the prediction. So once we gather the data, once we upload the data, once we choose our target variable and complete training, this is really where we can have fun with it. So on the right side, I'll start from the bottom. In Newton's third law, you're able to download the solution and deploy it either in a microcontroller or device on the edge in a different cloud or on your own workstation. The second option is REST API access. In this particular case, we have different sample codes of how to go ahead and access your models via REST API. But today, when you come back to start understanding your model after training is complete, what you'll do is you will enable predictions, and then you simply click Start Web Prediction. What this has done is it has uploaded the test data set. So this is all of the same information that you have without the target variable, because that's what we're going to want to predict. So let me just pull that up and show you. So as you saw earlier, job, education type, last contacted, all of those things. But as you can see, we don't have the target variable. And so this is what we're creating predictions. And then you can just click Start. For me, I've already completed this process yesterday. So now what you can do is click on the magnifying glass, and you can actually see all of the predictions that Newton has created. So everything to the right of this gray area are all of the data for your test data set. And then here we have all of the predictions that we've understood whether somebody has subscribed to a service or not. And to the right here, you can see the probability of this. So in this case, person number 11 did not subscribe, and we have a 99% probability that they aren't going to subscribe. So maybe this isn't a customer that we're going to want to look at. But as we look at person number 20 here that didn't subscribe, we actually see a 65% probability that they will not subscribe. So this might be an interesting customer to look at. So here, if you click on that particular prediction, we can look at the model interpreter. And this will show you all of the different features influencing the prediction, as well as what are the different changes we could do to help turn this person from a not subscribe to a subscribe. So here you see they will not subscribe with the 65% probability. And here we have all of the different features that are influencing this particular decision. Here, one of the features we have is the duration of the phone call that our sales agent was on with one of our customers. And this particular person talked for 513 seconds. And with that, they have a 65% probability of not subscribing to a particular financial service. Now, what the model interpreter allows you to do is adjust these values to see how it will change the resulting prediction. Now, if we move this value over to 739 seconds, there's a 52% probability that they would subscribe. So what does this mean for business? Well, now we can go back to our call center agents or our salespeople and help train them to be able to talk about more features of the credit card service, for example, and be able to have more talking points to keep people on the phone longer to increase the probability of subscribing. And if you see here, this steep hill will indicate each incremental change will have a large influence on the predicted value. But as it gets flatter, it has a lower incremental change. You can see if I go from 1,000 seconds, it's 62%. And if I go over to here, it's 66 seconds. And we can go ahead and look at days from the last campaign count. We can look at different categorical data. So last month was contacted. So you can actually see in the month of May, there's more people not subscribing, or more probability of not subscribing than subscribing. There's just a few more features I'd like to show you as well. We were talking a little bit earlier about the feature importance matrix. So this helps show you what are the top features and bottom features influencing your predictions. So here I can see duration, days from last contacted, European bond rate. These are the top features that are influencing the model as well. And we can also select the bottom. There are only 15 features, so you can see whether they defaulted or not as well. 1 second here, let me just reshare my screen. Okay. This can be very useful because maybe you don't necessarily want to continue to collect this data. And when we look at managing our models, we want to understand when our models begin to decay. So in this particular case, because the training data set and test data set are so relevant, right now we're at 100%. But say over the next couple of months, we're feeding in new predictions, and this begins to decay to maybe 80 or 70%. This tree will start to no longer look pretty and start to turn orange and yellow, and the leaves will fall off. This will indicate that you may need to retrain your model. And then here, when we look at the training tab, we've also added in automated exploratory data analysis. And you can actually pull this up before training is 100%. So maybe when it's at 20%, you can actually pull this up. And so what this helps you do is understand your overall data, for example. And in this case, we have 17,000 people who did not subscribe to the service, and 1,000 people and 2,000 people who did. So we can see it's slightly imbalanced. It will also tell you the different types of data that you have, whether it's text, whether it's float or decimals or integers. In this particular area, this is addressing continuous data. So right here, we're looking at the duration of the phone call in relation to the target variable. So what this is saying is a majority of your cases, people have spoken on the phone for about 200 seconds, and then lesser and lesser values as we approached 1,000 to 2,000 seconds. On the right side here, we can see how it's influenced. So in this particular case, people who were on the phone for less than 200 seconds had an equal amount of non-subscribe to subscribe. But if we look above 200 seconds, we have more examples of people who subscribe. So this could be a good influencing factor to look at how we can increase the duration of our calls and have more meaningful discussions. Then we can look at the discrete data. So this is all of the categorical data. So we were tracking the different job types of individuals, whether they be administration, blue collar, or students. And we can see the distribution based on the target variable. So there's a little legend up here. The dark green means not subscribed and the light green means subscribed. So here, if we can take a look here, we can actually see under students, about 50% of people subscribed who didn't subscribe. But when we look at administrative, very few subscribed versus non-subscribed. So we can then maybe look at the way that we're talking to individuals who are in this particular job type. This will just show the overall distribution. 89% of people did not subscribe and 11% did. And here, this is kind of one of my favorite visualizations, is our correlation heat map. So on the bottom, we can see what are the different features that are closely correlated with the target. So we can see duration of the phone call. We can see days from last contacts are highly correlated with the target. And then we can also see cross correlations between different features. So here, maybe the days from last contact is somewhat correlated with the European bond rate. And then if there are different types of problems, so in this particular case, we looked at binary classification. If we were to look at regression, you might see something like a violin plot and show outliers. If we do natural language processing, we might see different text bubbles and things like that. So depending on the type of problem, you're going to get different visualizations. So yeah, that overall is the quick kind of preview of the Newton platform. Hopefully all of you were able to successfully register and be able to get access to it. And so now we can go into some Q&A. So I'm just going to kind of back up here into the chat. So let me see here. All right. So it looks like there was some questions that Yulia had answered. So I'm going to scroll down a little bit here. Can I possible book GitHub data? Yeah, so We have our test drive version that allows you to play with all of the different features as well as the preloaded data sets. If you'd like to use your own data sets, you can subscribe for our Gravity version, which is also a free version, but there are infrastructure costs associated with that. However, if you're new to Google Cloud, you can get 300 free credits to use anywhere on GCP or Google Cloud platform, and you can use some of those credits towards training. And in that case, you could potentially do different tests with GitHub. So for example, we have a couple of ones from GitHub already, predicting the survival rate of Titanic or predicting Boston house prices. All right. Okay, please clarify that it is automated process, no need of code. How to bring alteration whenever required. How can I change the model efficiency values as per my requirement? So the entire process that I showed you required no coding at all. The web prediction tool allows you to understand and create predictions, so you don't need coding. And then how do I bring alteration whenever required? How do I change the model efficiency values as per my requirement? So once you've completely trained the model, you can look at the model quality. Now, the model quality of what you've created will be influenced by your data preparation. So all of the different features that you've included, you can use your expertise from a subject matter perspective and bring in those features. If you don't have a high quality, of course, you can reach us out on Slack and we can help you through that if there's any issues with your data. Or you can get additional features to continue to make iterations automatically and make your models better. And Newton will create a very efficient and accurate model within the first iteration. You have good data preparation. If the model is not as good, we can look at those as well. And yeah, as per your requirement, that would be creating a new model. How to change the features of the model. So in the preloaded data sets, you're not able to change the features. It's made that way as they're preloaded. However, if you were to create a model, your own custom model, once you've trained that and you've used it, if you want to then add or change features, you would do that in the preparation phase and then re-upload your data. Good interface. A few clarifications, please. Looks like an imbalanced data set. Why did the model choose accuracy, which is not necessarily appropriate for imbalanced data set? Yeah, so you're able to change the different metrics that you want as well. So from an imbalanced perspective, there's definitely a lot of information out there on the web to look at how to deal with those problems. So in this particular case, it was preloaded. Does the model iterate with multiple options, which is the final model chosen? How do I know that? So the platform itself uses our own internally developed algorithm that will create a model starting with a single neuron and finding connections to different features. It will cross-validate, add another, and continue to do this iterative process until it's reached an efficiency point. Then it will automatically stop training. So it won't actually go out there and search for different types of neural network or non-neural network algorithms on the market as maybe some of our competitors. So much, it's neural network, which is customized by your interface. Yes, so it does use a neural network framework that is patented and is internally developed, and we leverage that within the platform. Great question, Subramani. And Yulia's throwing in some links there. as well as some different benchmarks that we've done, whether it be or not or whatnot. So yeah, let me just quickly so once again, this is the QR for trying the platform out for free. Then we're going to be constantly doing additional master classes and different AI talent. Or as how can we develop soft skills? And so this is the QR code to join us in Slack. So yeah, go ahead and scan that and join us in Slack, like Yulia mentioned. In there, we're going to be sharing knowledge, answering questions, all of that good stuff.
Yeah.
So yeah, we did have one question about how efficient this model is in implementing time series. Yeah, so the test drive.
Yeah, it looks like Andrew lost the connection. Do you guys can hear me? Anyway, yeah, Andrew, hello. I think we lost you in the, yeah, like a couple of minutes ago. Can you hear us now? You are on mute.
Yes, I can. I believe there's a question about time series I was answering. I don't know.
Yeah. We stopped with this question.
Okay, sure. Yeah, so you didn't see it within the demo, within the test drive, but we do have an advanced mode that you're able to select different options about different time series and timing. One of the examples that we did was predicting the number of bikes that would be rented out at a particular time. So yeah, that would be an example as well. I don't know if there's any other questions, Yulia, that I wasn't able to see when I got disconnected.
I think by now we don't have more questions. We shared with you guys a link to Slack channel, so please welcome. I shared also with you some useful links for our benchmarks and information about our neural framework and about our approach to how we build very tiny model in order to embed them to devices. Actually, we do have special sessions about it. If you are interested in this topic, please come. We will plan it for November and December as well. So I don't see now more questions. If you have it, please, you are very welcome. Anyway, meanwhile you are thinking, I would like to say thank you, Andrew, for today's session. For whom joined us a little bit later, I would like to say that today is happy birthday of Andrew. Thank you so much. It's very amazing start of your day. We wish you happiness, good luck, and health. So yeah, guys, if you don't have more questions, as I told you, please stay aware, because we will upload the results of our book away in a few hours in our Slack channel. So just come and check if you are lucky one. Yeah, we will be very happy for you. So I hope that today's session was pretty useful for you. In any case, we will share also our contacts. Andrew, could you please share your email if someone would like to ask you additional questions? And we also do online onboarding if you need some questions meanwhile you are starting to use our platform. Also in our platform, we do have a lot of preloaded data sets from different industries, so you can practice even you don't have the real data, but you can practice, for example, if you're interested in finance industry or marketing or wherever. So please welcome. Also, we have very large library where you can also maybe to know something new about metrics, about data, about models. So also please use it. And yeah, we will be on live next week, so please stay tuned, and we will be very happy to see you within our AI Talent Lab.
Awesome. Yeah, thank you, Yulia, for coordinating all of this. Thanks to Harpreet for the great MLOps strategy discussion earlier today as well from Comet. And yeah, I look forward to seeing all of you at the next sessions. Thank you so much.
Thank you. Bye-bye.